Hi guys, happy morning. In the last class, we had discussed the very important the Karl Pearson coefficient for group data. Imagine the Karl Pearson coefficient of group data formula capital N Rxy is equal to capital N double summation fxy dx dy minus summation fx dx into summation fy dy whole divided by root of capital N summation fx dx square minus summation fx dx whole square into n summation fy dy square minus summation fy dy whole square. Hope you almost we are 10 problem we did compulsory. This is a very important question, 10 mark. Please concentrate. Okay, but today we are discussing for the second type of method of correlation that is called Spearman. Yes, P-E-A-R-M-A-N, yes, Spearman's Spearman rank correlation coefficient. It's a very, very important, guys, important one. Spearman rank correlation coefficient. Okay. And note that in the Spearman rank correlation coefficient, we have a two types. One is called rank without ties and another one is called rank with ties. Let me discuss what is actually Spearman rank correlation coefficient. Okay, please start down. Karl Pearson coefficient of correlation, that is R, can be calculated only if the variables under study are quantitative. Yes, look at that. It's a very important. The Spearman rank correlation coefficient, and that this why we need to study for Spearman, that is important. Karl Pearson coefficient of correlation, that is denoted as R, can be calculated only if the variables under study are quantitative. All of you are aware it quantitative, nothing but the data can be a measurable, some unit of measurement, right? Yes, that is called quantitative. However, if the variables are qualitative, in nature, qualitative nothing but data cannot be measurable, qualitative in nature, we calculate Spearman, S-P-E-A-R-M-A-N-S, Spearman's rank correlation coefficient. However, if the variables are qualitative in nature, we calculate Spearman rank correlation coefficient, okay, which is denoted by rho, Yes, I'll give you the notation there, okay, which is denoted by rho. So how it is that notation? So just a minute. The notation is like this. This is a row. Okay, I repeat once again. This is nothing but row. Yes, look at it. This is row. The Spearman rank correlation coefficient is denoted as a row. Okay. The next line. Here we assign ranks to the characteristic characteristics under study, and then for these ranks and then for these ranks, or calculate Spearman rank correlation coefficient. Here we assign rank to the characteristics under study, and then for these ranks are calculated Spearman rank correlation coefficient. Let's take down next one. We have two types of rank correlation. We have two types of rank correlation, namely, number one, rank without ties. The second one, rank with ties. Okay, can we go the first one now? This is very important. The first one we are able to write rank without ties. Rank without ties. Okay, please all of you make side note, rank without ties. So what is the formula, the rank without ties? Okay, rho is equal to, the formula is given by 1 minus 6 summation d square divided by n cube minus n. Okay, so this is the formula for rank without ties. Okay, where d is equal to R1 minus R2. R1 is equal to rank in X series. R2 is equal to rank in Y series. And n is equal to number of paired observation. Number of paired observations. Okay, so this is rank correlation coefficient without ties. Okay, can you go for other one? Yes, second one. Rank correlation coefficient with ties. Okay, right? The formula is given by rho is equal to 1 minus 6 summation d square plus m1 cube minus m1 divided by 12 plus m2 cube minus m2 divided by 12 plus etc. whole divided by n cube minus n. So this is the formula for Spearman rank correlation coefficient with the ties. Okay, where already we know d is equal to r1 minus r2, m1 is equal to number of times value repeats, m2 is equal to number of times second value repeats, and so on. Okay, after this, where small n is equal to number of paired observations, okay, number of paired observations. Okay guys, can you go for the first problem? Please remember, all of you, Spearman rank correlation coefficient denoted as rho, but call Pearson coefficient of group data, ungroup data. All the data should be measurable, the data should be a quantitative in nature. But why we are using Spearman rank correlation coefficient with ties and without ties? The main reason is if both the variables are qualitative in nature, that is the data cannot be measurable. Remember in first chapter, we already discussed the one thing is the nominal scale, ordinal scale, the data cannot be measurable for the qualitative variable. Same thing here also, we are able to find the relationship between the two variables. The data should be a qualitative in nature. Definitely there's one of the measurement that is called correlation, and the Spearman rank correlation coefficient. Okay, that we go the first problem now today. Please all of you get ready, take your calculator. Yes, now we are going to discuss the first problem. Yes, take on the first problem here. Okay, take on the first problem. Calculate. Yes, we can write the first problem. Okay, calculate Spearman rank correlation of coefficient. Okay, calculate Spearman's rank correlation coefficient. Okay, just ready for the first question. Okay, the first question here, that should be your data is called X and this is called Y. Okay, X and Y. Okay, X data here 25, 43, 27, 35, 54, 61, 37, 45. Okay. So just a minute. $45. Okay. Yes. Okay. Why? Now 35, 47, 20, 37, 63, 54, 28, 40. Yes. So this is the first problem for Spearman rank correlation coefficient for width type. Remember in the examination, suppose somebody asks how to identify with ties or without ties. Please look at that X and Y column. Any numbers, highest numbers are, or any number you can repeat it twice. Can you check now? 25, 43, 27, 35, 54, 61, 37, 45. Yes, the numbers are not repeated. Here also 35, 47, 20, 37, 63, 54, 28, 40. Yes, especially this problem is without type because numbers are not repeated. Okay, can we go for now important one? So before that we are able to write formula. So that should be important. Formula: rho is equal to 1 minus 6 summation d square divided by n cube minus n. So this is the formula for Spearman rank correlation coefficient without ties, where D is equal to R1 minus R2. So this is the formula, R1 minus R2. Okay. Now we'll get into the first column. So what we need to calculate. Okay. The first thing we're able to write R1, the second R2, then small d is equal to, small d is equal to R1 minus R2. Okay, R1 minus R2. Yes, R1 minus R2. That is D is equal to R1 minus R2. Okay, let me go one by one. So how to do R1? Look at that, already we know R1 nothing but rank in X series. Imagine rank in X series. Look at that, in X series, this is the highest one. Yes, highest one is 61. Put rank number 1. Similarly, second highest number 54. Yes, second rank. Third highest number 45. Yes, third rank. Then fourth one 43. Okay, this is a fourth rank from highest to lowest. Okay, after fourth rank, which is the fifth one, okay, yes, 37. The sixth one 35, seventh one 27, and 25 is the eighth one. Okay, so these are the ranks of X, X nothing but R1 series. Now we are going to R2. So what is R2? Which is the highest one here, which is the highest rank in Y column. That is 63. Yes, first rank. Similarly, there is a 54 at the second rank, and 47 is the third rank. Okay, and fourth rank is 40. Fourth rank is 40. Then fifth rank, yes, 37. Sixth rank 35. Seventh rank 28. Now last one, 8th rank. Okay, now subtract 8 minus 2, there is a 2. Okay, we'll make out another one more column because we need d square column. Yes, so this is d square. This is for d square. Okay, 2 square is 4. Okay, 4 minus 3, 1. 1 square is 1. Similarly, this is minus 1. 1 square is 1. This is 6 minus 5 is 1. 1 square is 1. 2 minus 1 is 1. 1 square is 1. Sorry. 1 minus 2 is minus 1. That square is 1. Similarly, minus 2, minus 2, then 2 square is 4. And here minus 1, there is a 1. Okay. Yes, now we need to total of summation d square. What is the summation d square total? Here, sum of d square in this place. Okay, summation of d square, can you count? 4, 5, 6, 7, 8, 9, 10, 14. Yes, summation d square is equal to 14. Now we are getting to the substitution part. Let me check substitution part. So what will be the answer? Okay. Substitution part. Rho is equal to 1 minus 6 summation d square. We got 14 divided by n cube minus n. Rho is equal to 1 minus. This you can calculate directly in your scientific calculator. Please do what I'm saying. Take your calculator, open bracket, 6, open bracket, 14, close bracket, again close bracket, divided by, open bracket, press button 8. Look at that in your calculator, there is this type of shape button, that is an at after x square. Just put 8 at 3 minus 8, then close bracket. Then close bracket. So what will be the answer? I repeat once again, open bracket, 6, open bracket, 14, close bracket, again close bracket, divided by, open bracket, 8, press this at button, cube minus 8, close bracket. I got answer 0.1667. 0.1667. Similarly, rho is equal to 1 minus that answer, the total answer here, 0.8333. Yes, this is the answer, 0.8333. Okay. Now comment. Comment, we are going to write comment. So there exists fairly high degree positive correlation between x and y. Yes, comment. There exists fairly high degree positive correlation between x and y. Yes, this is the first problem for Spearman rank correlation coefficient for group data. Yes, not group data, sorry. Spearman rank correlation coefficient. Spearman rank correlation coefficient without types. Okay, can we go for second sum? Okay, second problem, guys, get ready. Second problem, same thing. Calculate Spearman correlation of coefficient from the following data. Okay. Yes, calculate Spearman correlation coefficient, Spearman rank correlation coefficient from the following data. The first question, X column and Y column. X column and Y column. The X column here, X column 46, second 56, 39, 45, 54, 58, 36, 40. Okay. Then we go for Y column. Yes, Y column 30, 60, 40, 50, 70, 65, 39, 52. Okay, yes. Write on the formula first. Rho is equal to 1 minus 6 summation d square divided by n cube minus n. Can you check what is n here? N is equal to 8. Okay, n is equal to 8. Can we start the first rank in X series? That is 58, first rank. The second one, 56. Second rank is 56. Third rank is 54. Fourth rank is 46. Sorry, fourth rank. The fifth rank, 45. 45. Okay. Sixth rank is 40. 40. Seventh rank, 39. Eighth rank, 36. Oh, sorry. Yes. Now successfully completed. Now for R2. First rank is 70. Okay. The second rank, 65. Okay. Third rank is 60. Third rank is 60. The fourth rank is 52. Fourth rank. Fifth rank, 50. Fifth rank is 50. Then sixth rank is 40. Seventh rank is 39. And last eighth rank is 30. Okay. Can we move on subtraction? 4 minus 8 is minus 4. The 4 square is 16. Okay. Minus 1. 1 minus 1 square is 1. There is a 1. Then 1 square is 1. 0. 0 square is 0. 2. 2 square is 4. Minus 1. 1. Plus 1. There is a 1. 2. Then 4. Yes. Can you have a total for summation d square? Okay. Summation d square is equal to 16, 17, 18, 19, 20, 24, 28. Yes. 28. Summation d square is equal to 28. Yes, now we are going to substitute summation d square in the formula. Okay. Yes, we are going to write formula. Rho is equal to 1 minus 6 summation d square is 28 divided by 8 cube minus 8. Okay, rho is equal to 1 minus all the thing that calculation is. So just a minute. So calculator 168 divided by 504. I got 0.3333. The final answer rho is equal to 0.667. So what is the comment here? Comment on this one. Comment. There exists moderately high positive correlation between X and Y. Okay, so this is the second problem. Okay, thank you.